With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, let's take a question here. The question is, a compound is composed of 2.2% hydrogen, 26.6% of carbon and 71.2% of oxygen. Okay, so calculate the empirical formula of the compound, and if its molecular mass is 90, find its molecular formula also. Okay, so empirical formula is the simplest ratio of the atoms. It is a simplest ratio of the atoms, present in a compound, okay. And if we need to calculate the molecular formula, so what we will do is molecular formula is equal to n into the empirical formula. Here I have written the short form, okay, n into the empirical formula. Now here our n is equal to the molar mass, okay, that is molecular mass that is given, okay, upon the empirical formula mass, okay. So what we will do now, we have to calculate the empirical formula mass, and here we are given with the variance different percentages present in a compound, okay. So what we will do, let the molar mass, here it is molecular mass, okay, which is given in the question. Now we have let the molar mass to find the empirical formula, okay. The molar mass of compound be 100 grams, okay. So in the question we are given with the percentage hydrogen, carbon and oxygen. We are given with the percentage hydrogen, carbon and oxygen. So here percentage is 2.2%. Let's first write the percentage. 2.2%, 26.6% for carbon, and for oxygen it is 71.2%. So if we have let that the molar mass of the compound is 100 gram, it means that it has 2.2 gram of hydrogen, 26.6 grams of carbons and 71.2 gram of oxygen. So from here we can calculate the number of moles. Number of moles is equal to given mass, this one, upon the atomic mass. So for hydrogen it is given in the question, it is not given, but we know that for the hydrogen the atomic mass is 1, so 2.2 by 1. For carbon we know that it is 12, so it is 26.6 by 12, and for oxygen 71.2 by 16. Now if we solve this value, here it will be 2.2, here also it will be 2.2, okay, and here it is 4.4. Here it is 4.4. Now to calculate the empirical formula, we need to calculate the simplest ratio. And simplest ratio is the number of moles calculated. These are number of moles, right? Number of moles calculated by the smallest number. So here our smallest number is 2.2. So what we will do, 2.2 by 2.2, 2.2 divided by 2.2 and 4.4 divided by 2.2. So now if we solve these values, so here we will have, here it is 1, here also 1, and here we have 2. Okay, so this was our hydrogen, carbon and oxygen. Okay, hydrogen, carbon and oxygen. So it means for carbon ratio to hydrogen to oxygen, we can write the empirical formula. To write the empirical formula, now we have the ratio, that is 1:1:2. So in EF, that is empirical formula, it is equal to CHO2. Okay, now we can calculate the empirical formula mass. Mass of empirical formula. So mass of EF, that is equal to C, mass is 12, hydrogen 1, plus here we have the 2 atoms of oxygen, so it will be 16 into 2. Okay, so it is 12 plus 1 plus 32, right? So it is equal to 45. Now we are given the molecular mass in the question, molecular mass of the compound, and that is 90. So now for molecular formula we have N into empirical formula, and we have already discussed that the value of N is molar mass, okay, molecular mass upon empirical formula mass, right? So here our molecular mass is 90. Here our molecular mass is 90, okay, upon empirical formula mass, that is 45, okay, and into we have CHO2, that is our empirical formula, right? So here we have 2 into CHO2, so here it will be C2H2O4. So this is our required answer, that is the molecular formula and the empirical formula of the compound. We need to calculate it, the both things, okay? So here our empirical formula is CHO2 and the molecular formula is C2H2O4. So this is our required answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.